Welcome, friends, to our quiet corner of the internet. It is a pleasure to have you here for another late-night conversation about the world and the universe as we know it. Tonight, we are looking at an entity we often take for granted, the sun. We see it as a dependable friend that marks our days and warms our skin. But if we are being honest, the sun is also a massive, churning nuclear furnace that does not always play by the rules. In our modern lives, we have become incredibly efficient at building fragile miracles. We have high-speed internet, global power grids, and GPS systems that can find a coffee shop within 10 feet of our location. It is an impressive achievement, but it all relies on a very quiet and cooperative space environment. However, every now and then, the sun decides to clear its throat in a way that could, quite literally, unplug our entire civilization. We call these events solar storms. They are not malevolent. They are just the natural result of a star being, well, a star. But for a society that considers a 10-minute Wi-Fi outage a minor national emergency, a major solar event is the ultimate reality check. It is the universe's way of reminding us that while we might run the planet, we do not run the solar system. Tonight, we are going to explore the fascinating, slightly nerve-wracking, but ultimately human story of what happens when the sun's magnetic fields decide to throw a curveball at our digital lives. It is a tale of history, science, and the quiet resilience of a species that is always trying to stay connected. Before we venture into the heart of the storm, I would like to invite you to join our community. If you appreciate this blend of curiosity and calm, please consider hitting the like button. It is a small gesture, but it helps our stories reach others who are looking for a bit of perspective. And if you would like to stay for future journeys, do subscribe and turn on the notifications. We are glad to have you with us. Now, let us settle in and look at the star of our show. The sun operates on a cycle, a bit like a cosmic clock that hits a frantic mode every 11 years. We call this the solar maximum. During this time, the sun's magnetic fields get tangled and twisted, building up immense pressure. Eventually, that pressure has to go somewhere. The result is a coronal mass ejection, or CME, a massive cloud of solar plasma hurtling through space. If the Earth happens to be in its path, it is less of a collision and more of a magnetic handshake that is a bit too firm for comfort. When a CME reaches us, it interacts with Earth's magnetic shield. This is what creates the beautiful auroras, those dancing ribbons of light in the polar skies. They are spectacular to look at, but they are also a visible sign that our planet's defenses are working overtime. The real trouble starts when these magnetic disturbances induce electrical currents in our ground-based infrastructure. To understand the scale of this, we have to look back to 1859 and the Carrington event. At the time, the world was just beginning its love affair with electricity via the telegraph. When the solar storm hit, the telegraph wires began to act as giant antennas, sucking up energy from the atmosphere. Machines sparked, paper caught fire, and some operators reported they could send messages even after disconnecting the batteries. It was a bizarre, early warning of what happens when the sun decides to join our electrical network without an invitation. In 1859, the impact was a curiosity. Today, it would be a crisis. Our modern power grids are built on massive transformers that are essentially the organs of our electrical system. They are designed for very specific types of current. When a solar storm pushes DC current into these AC systems, the transformers can overheat and melt. These are not parts you can simply replace overnight. They take months to build and specialized ships to transport. A major storm could leave entire regions in the dark for an uncomfortably long time. Then, there is the internet, the nervous system of our modern world. While the fiber optics in your home are immune to magnetic interference, the long-distance cables under our oceans are vulnerable. Every 50 miles or so, these cables have repeaters to keep the signal moving. These repeaters rely on electricity, and a geomagnetic storm could easily knock them out. Imagine the internet not as a cloud, but as a series of islands that suddenly lose their bridges. the global flow of information, finance, and logistics would simply stop to catch its breath. Our satellites are even more exposed. Orbiting outside the protection of our atmosphere, they are the first to feel the heat. A severe storm can fry their delicate electronics, turning billion-dollar navigation and communication tools into very expensive space junk. Without GPS, the complex choreography of global shipping and aviation would fall out of sync. Your phone would not just lose its map. The world would lose its sense of time and place. Now, this sounds like a dark forecast, but there is a lighter side to it. Human beings are remarkably good at adapting when things go wrong. If the screens went dark, we would not just stop existing. We would find new, or rather, old ways to connect. We would rediscover the value of community, the reliability of a physical book, and the fact that our neighbors are actually quite interesting when we are not both staring at our phones. Scientists are working tirelessly to give us a weather report for space. We have satellites positioned to give us about a 30-minute warning before a CME hits. It is a short window, but it is enough for power companies to adjust their loads and for satellite operators to put their equipment into safe mode. We are learning to live in harmony with our star's temper. The sun has been there for billions of years, and it will be there long after our current gadgets are in museums. It is a healthy reminder of our place in the cosmos, hitchhikers on a beautiful, blue planet, trying our best to keep the lights on while the stars do their thing. As we draw our story to a close, it is worth reflecting on the balance of life. We live in an incredible era of technology, but that technology exists within a much larger, more powerful natural system. The threat of a solar storm is not something to lose sleep over, but rather a reason to appreciate the stability we have right now. Tonight, as you see the glow of the lights in your home or the steady signal on your device, take a moment to appreciate the invisible shield that makes it all possible. We are part of a grand cosmic dance, and sometimes the music gets a little loud. But the dance continues. If the lights ever do flicker and go out for a while, remember that it is just the universe's way of hitting the pause button. Perhaps the real lesson of the solar storm is that our most important connections are not made of silicon and gold. They are the connections we have with the people around us, the stories we share, and the curiosity that keeps us looking at the stars. No magnetic field can disrupt the warmth of a good conversation or the peace of a quiet night. Thank you for spending this hour with us. Your time and attention are the most valuable things you can give. And we are grateful to share these explorations with you. As you settle into the comfort of your evening, let the vastness of the universe inspire wonder rather than worry. The sun is quiet for now, the grid is steady, and there is peace in the night. May your rest be deep and restorative, and may your dreams be filled with the quiet beauty of the cosmos. Tomorrow is a new day with its own stories and its own light. Thank you for listening, and thank you for being a part of our journey. Good night, everyone. Sleep in peace and wake with joy.